Due to the increasing number of turbocharged vehicles on the road these days, the automotive technician needs to be aware of what causes faults within these systems. This diagnosis refers to OEM systems and may not apply to aftermarket turbocharging. The position of the turbocharger wastegate valve is generally controlled by the engine control module, or ECM. The ECM uses a turbocharger control solenoid and a boost pressure sensor to control the turbocharger wastegate. The ECM uses PWM on the control circuit to activate the solenoid valve. The turbocharger pressure sensor responds to pressure changes in the intake manifold. The pressure changes occur based on engine load and turbocharger boost. The engine control module supplies 5 volts and a low reference to the turbocharger pressure sensor. The turbocharger pressure sensor provides a signal to the ECM, which is relative to the pressure changes in the manifold. Overboost DTCs will be logged when the ECM determines that the actual boost pressure is higher than the desired range for a predetermined time. The check engine light will be illuminated, and the ECM may command a low power or limp mode for engine protection. We need to look for any reason the ECM cannot control boost pressure to its specified limits. Non-OEM wheels, exhaust systems, modified intake systems, and piggyback controllers may cause these faults. When diagnosing, check for the presence of any aftermarket equipment. It may be necessary to check the vehicle's freeze frame data to help reproduce the conditions at the time of the fault. With the engine running, hold the engine speed to around 2000 RPM. Command the turbocharger wastegate open, then closed. Observe the boost pressure sensor data and verify the sensor parameter changes with the scan tool commands. If the boost pressure data does not change in relation to scan tool commands, it will be necessary to perform a visual inspection of the system. Inspect the boost pressure sensor for damage, blockages, or a leaking seal. Check the harness connector for security. Inspect the air filter and intake system for damage, modifications, or abnormalities that may allow higher than normal airflow. Check for seized or binding linkages, damaged or leaking vacuum and pressure hoses. Check for sticking, broken or missing components or debris in the turbocharger. Pay close attention to the wastegate. Inspect the exhaust system, as leaks here may result in a loss of back pressure, causing the turbine to spin faster and producing an increase in boost pressure. Inspect the wastegate solenoid valve for leaks or damage. Inspect the mechanical operation of the solenoid valve. This can be done with a hand-operated vacuum pump and a scan tool. Apply vacuum to one side of the solenoid. The valve should hold vacuum until commanded with a scan tool. When activated, you should be able to hear the solenoid operating and see the vacuum decreasing. Overboost codes on a wastegate turbocharger may be caused by a faulty solenoid or solenoid control circuit. We need to determine if the wastegate solenoid valve is receiving commands from the ECM before condemning this component. Let's test the electrical circuit now. Turn on the ignition. With the meter set on volts and one lead connected to ground, back probe each terminal of the solenoid. Battery voltage should be evident on each terminal. This indicates a correctly operating supply circuit and a voltage path through the solenoid. If voltage cannot be found on the supply side of the solenoid, locate the circuit supply fuse and inspect for opens. If the fuse is OK, test for voltage on the supply terminal. If voltage is available, check the fuse holder terminals for correct tension. If this is OK, then there is an open between the wastegate control solenoid and the fuse. If the correct voltage can only be found on one side of the control solenoid, there will be an open in the solenoid. This can be confirmed by disconnecting the solenoid and performing a resistance test across the terminals. This ECM controls the wastegate control solenoid via pulse width modulation of the low side circuit. This test is best performed with an oscilloscope and scan tool used together. Back probe the low side terminal of the control solenoid with one channel of the scope. Using a scan tool, activate the wastegate control solenoid. You should see a square wave pattern that reflects the scan tool command. A steady battery voltage signal may indicate an open circuit or short to voltage on the low side path. If you don't have an oscilloscope, then this test may be carried out using a multimeter. With the meter set on duty cycle, connect 1 meter lead to battery positive and back probe the control solenoid low side circuit with the other. Using a scan tool, command the wastegate control solenoid to maximum and back to minimum. The meter should reflect the scan tool command. To test for a short to voltage, turn the ignition on, disconnect the control solenoid and connect the meter between the low side terminal on the harness connector and battery negative. If the meter displays a significantly high voltage, then there is a short to voltage in the circuit. With the ignition off, disconnect the ECM. Turn the ignition back on and observe the meter. If the meter still displays a voltage, then the short is in the harness between the two connectors. If the meter displayed 0 volts with the ECM disconnected, then the short to voltage is in the ECM or another circuit from the ECM. To isolate, set the meter to ohms and test for continuity between the solenoid low side terminal in the harness connector and all other terminals in the ECM connector. If any reading is found, then the short is in that circuit. If the meter displays an open circuit, then the short is in the ECM. To test for an open in the control circuit, connect the meter between battery positive and the low side control terminal in the wastegate solenoid harness connector. Using the scan tool, activate the wastegate solenoid to 100% and monitor the meter. The meter should display battery voltage. If there is no voltage displayed on the meter, back probe the control circuit at the ECM and repeat the test. If battery voltage is now displayed, then the open is in the harness between the ECM and solenoid connectors. If the meter did not display a voltage, disconnect the ECM connector and inspect the solenoid control terminal for corrosion and correct terminal tension. If this is okay, then the open is in the ECM. Once repaired, perform the drive cycle for that DTC and recheck for fault codes. Always test and confirm your diagnosis before replacing any parts. Remember, a well-trained technician is a skilled technician. Thanks for watching.